Okay, so this is the modeling formative that I'm going to sort of record over here. It's out of 63 marks. This is the practice paper. Now here in an ecological experiment, the number of mosquitoes placed in a container with water and vegetation. The population has been given over here. So the population is given by PT is equal to 24 into 4 raised to 0.385 t, where t is greater than or equal to 0. Where t is the time in days since the mosquitoes are placed in the container. Find the number of mosquitoes initially placed in the container. So to find out the initial value, you put time as 0. So we will find P0. So 24 into 4 raised to 0.385 raised to 0. So basically that will be 24 into 4 raised to 0. You can put in a calculator, you will be left with 24. So basically whenever we have exponential modeling, this will basically this number is the initial population. 24 is the initial population. Now second part, what we are doing is in the container after 5 days. So if you want to find in the container after 5 days, you find out P5. So you'll do 24 into 4 raised to 0.385 raised to 5. So put that on your calculator. So 24 into 4 raised to 0.385 into 5. Correct? So that is because it's a number of days only. So 346. So this would be basically 346. Correct? So 346 mosquitoes would be there in that. The maximum capacity of the container is 5,000 mosquitoes. Find the number of days. So now the population is 5,000. So now we have that P is equal to 24 into 4 is to 0.385 t. Now they've given you this population. There are two variables, population and time. So now they've given you the population. The population is 5,000. 24 into 4 raised to 0.385 raised to t. So basically put solvent and solve for t. So let's do that. Let's see my calculator. So I'll do option calc solvent. You do 5,000 is equal to 24 into 4 raised to 0.385 x. We'll put t as x. Correct? You're solving for variable x. Correct? So you can just put solvent. Once you put that, you get 10. So basically 10. So it will take 10. So t is equal to 10 days. So 10 days it will take for the population mosquito to reach this, to reach 5,000. An ice cube is dropped in a cup of water, a cup of warm water. The weight of the ice cube W in grams reduces as the ice cube dissolves in it. The weight can be modeled by the following function: Wt, where t is the time in seconds after it starts dissolving. This is the model given. So the weight, which is a function of time, is 28 into 0.98 raised to t. T is greater than or equal to 0. Find the initial weight. So whenever this initial comes in, you have to put time as 0. So you put time as 0 in this case. So W0 is equal to 28 into 0.98 raised to t. So t is 0. Anything raised to 0 is 1. So 28 to 1, that's 28. Remember, whatever this is, this would be initial. In the last sum also, if you see it, correct? So this was the initial. This value is the initial. So that's always the initial value. Okay, but it's better that you put time as 0 and get that. That's the first part. The percentage of ice that dissolves every second. Now this is a tricky one. So in this case, if you see that 0.98 is a factor, this is the factor that we have. So whenever you do 0.98, means it's 2% reduction. It's 2% reduction. No, 5 seconds, oh sorry. So if you want 5 seconds, then you have to do 0.98 raised to 5. 2% reduction every second. Correct? So 0.98 raised to 5 you do. So when you do 0.98 raised to 5, so let's do that. So 0.98 raised to 5. If you work that out, so that's your 0.904. 0.904. So you do 1 minus 0.904 means your initial value is 1. You do 1 minus that, and to convert into percentage you multiply that by 100. So that will give you the percentage reduction in 5 seconds. So basically you do 1 minus answer shift, and this is answer. Correct? Fraction, you multiply that by 100 to convert this into percentage. So that's 9.61%. So 9.61% is the percentage reduction. So 9.61% is the ices melting. Yeah, we can do that. B, calculate the weight of the ice remaining after 1 minute. Now this is very important. This is in seconds. So 1 minute is 60 seconds. So basically you put your time as 60. Remember, this model takes time in seconds. So W in 60, 28, 0.98 raised to 60. So you want 60 seconds, 1 minute is 60 seconds. So use your calculator. 28 into 0.98 raised to 60. 8.33. So 8.33 grams. Rounding is correct here. 8.33 grams will remain after 1 minute. The next one is a trigo modeling question. The average daily hours of sunlight during 12-month period in a particular town is given by the function St is equal to A cos Bt minus pi plus D, where T is measured in months, A and D are constants, and B is measured in degrees. So B is in degrees. This is important. Okay. So S versus time is shown in the diagram. Find out the amplitude A. Now to find out A, what you need to do is the following. You need to find out the max value of Y. The max value of Y on the y-axis, this is my y-axis, the max value of Y is 16. This is the maximum value, 16. You find out the minimum value of Y. Minimum value is 4. Minimum value is 4. Now what you need to do is, your A is equal to max Y minus min Y divided by 2. So your max Y is 16 minus min Y is 4 divided by 2. So that's how much? 12 divided by 2. So that is 6. Your D is equal to max Y plus minimum Y divided by 2. So 16 plus 4 divided by 2, it's 20 divided by 2, which is 10. There's one more way of looking at it. This middle line here is your D, which is 10. So basically your D is 10, and your amplitude is this distance. Correct? So from 10 it's going to 16, so amplitude is 6. So this amplitude is 6, and this B is equal to 10. That's another way of looking at it. The value of B, I'm writing it here, so because of B is equal to, it sits in degrees, you have to do 360 divided by the period of the graph. Now what exactly is the period? Period is one cycle. So if you take minimum to minimum is one cycle. So minimum to minimum, see, so whenever you're looking at period, either you look at max to max, or you look from, if it's like this, you look from min to min. Okay, so in this case the period is from minimum to minimum. So 360 divided by, so here it was 0 and here it is 12. So the period here is 12. So divide by 12. So 30 degrees. Write down the temperature when the average daily sunlight is 10 hours. So when the daily sunlight is 10 hours, write down the values of T. So basically now my model becomes y is equal to A is what we got, A is 6 cos, B we got as 30T minus pi plus D value we got 10. Correct? So now what we have to do is write down the values of T when the average is 10 hours. So 10 hours is basically your only. So I'm getting this and this. So when it's 10 hours, we have at 3 hours. T is measured in month. So this is the sunlight in hours. So 10 hours is at 3 and at 9. 3 and 9. So T is equal to 3. T is equal to 3. This part C, and T is equal to 9. Correct? Then when T is equal to 3, T is equal to 9, we have the daily sunlight is 10 hours. So when the number of hours are 10, you're finding this. So you're looking at 10, you're finding this. That's what we are doing. Now in this case, the water depth in meters on the harbour is given by this particular model. So it's been given that D is equal to 3 sine 30 degrees into T plus 5, where T takes 0 to 24 hours, which you can see. So the minimum 0, this is 24, and this is your D is given over here. Draw a graph. So draw the graph, you have to simply type this in. Okay, you simply type this in. So in your calculator 3. So what you need to do is, this is a radian mode. So make it a point, you press shift, setup, go make this into degree mode. Okay, exit, go to menu, go to graph. Now you need to delete anything which are there. Type in 3 sine 30t, 3 sine 30x close brackets plus 5 plus 5. Correct? You see the graph. Now view window is important. Your x is 0 to 24. You look at this. So 0, 24. So 0, 24. Correct? You go down. Y is from 0 to 10. So 0, y minimum is 0, y maximum is 10. You have your graph. Press enter again. So this is the graph you see. Now what you need to do, you need to copy this graph. So what I need to do is, I need to understand that this midline is 5. So this midline here is 5. Midline is 5. Amplitude is 3. So maximum value is 3 plus 5. Maximum value is 3 plus 5 is 8. So this is your A, this is your D. Your maximum value will be D plus A. That's 5 plus 3. 5 plus 3 is 8. Minimum value is 5 minus 3. D minus A. That's 2. So this is your max value. And this is your min value. Now period is 30. So what you need to do in this case is, you look at this graph. So now we are getting 2 lines over here. So what I do is, I'll press exit, and my midline is 5. I know that over here. So I press 5 over here. Correct? So this is my midline. I'll see where do they intersect. So G solve, intersect F5. So it's 0, it's intersecting. Then it's intersecting at 6, 5. Then it's intersecting at 12, 5. Then it's intersecting at 18, 5. Then it's intersecting at 24, 5. So 0, 6, 12, 18, 24.